All right, so in this video, I'm going to go over a couple problems that is on your Ohm's Law practice. This assignment is in your fourth packet. That is the week of 4/27, April 27th there. And this assignment is having you calculate a few things given Ohm's Law. So just a little bit of review here first. What is Ohm's Law? Well, Ohm's Law basically can be summarized by this equation, and it is V equals I multiplied by R, or voltage difference equals current multiplied by resistance. So hopefully from your notes, you know that voltage difference is basically just a measurement of the force that is pushing electrons. That's all electricity really is. It's just the flow of electrons, those tiny subatomic particles that have a negative charge. So realistically, voltage is the force that is pushing those electrons. I here, or current is just a measurement of the movement of those electrons. So how many electrons are moving in a single direction, basically. Or you can think of it almost as how quickly or how many are flowing in a single direction. So the higher the current, the more electrons that are flowing past a single point or direction. And then lastly here, R is just resistance. So basically, what we'll learn later is that certain materials have higher resistances, meaning that they oppose the movement of electrons. That's all resistance really means, is that you're opposing the movement of electrons. So for instance, some things like rubber has a really high resistance. Rubber's not going to be able to allow electrons to pass easily through it. But something like copper, which is what we use for a lot of wiring in our homes and electronics, copper has a very low resistance, meaning it's going to let electrons pass very easily. So that's really just what resistance is. So resistance basically opposes the movement of electrons. Current is a measurement of the movement of those electrons. And voltage is basically the force, a measurement of the force that's going to push those electrons. So that's everything right there. So let's start off with a simple problem here. And we have number one here. Number one states, what voltage produces a current of 100 amps with a resistance of 50 ohms? So we have to use our formula here to figure this out. And the nice part is I've included this triangle on your assignment as well. But this applies to Ohm's Law very nicely because you can use this triangle to kind of figure out what you have to do. So remember, in this triangle, if you're trying to find voltage, for instance, which is what we're trying to do in this problem, then what you would do is you would look at, well, current and resistance, they are right next to each other. So in this case, what we're going to do is we're going to multiply these two values, which is exactly what this equation tells us to do. But we read through the problem. Next thing we should do is probably define what values we are given. We already said that we had a current of 100 amps. So I will write 100 amps right there. You can also write amps as just a capital A if you would like to shorten it up a bit. Either will work fine for this class. And then we said we had a resistance of 50 ohms. So you can actually write out ohms, or what you can do is you can put an omega, the Greek sign for omega. It also just means ohms. So we have 100 amp, 50 ohms. We look at our equation, or we look at our triangle here to help us out, and we figure out that we have to multiply those two values. So not too bad, it's just 50 multiplied by 1,000, and what you should get is that you have a voltage difference of 5,000 volts. And all I have to write is V there, so 5,000 volts, because we do measure voltage in volts. So I'm going to show you another example problem here. We're going to do number 5 on our Ohm's Law practice. Number 5 says, what resistance would produce a current of 120 amps from a 6-volt battery? So the next thing we got to do here is define what variables we are given. We just stated that we have a 6-volt battery, and we have 120 amps of current coming from this battery. So there's our variables right there. If we look at our equation, or we look at the triangle over here, we know that we have voltage and current. We are looking for resistance. So in the triangle here, voltage is above current. So realistically, it should be voltage divided by current. So what we'll do here is resistance is going to equal voltage of 6 divided by 120. If you do 6 divided by 120, what you should get is a resistance of 0.05 ohms. Ooh, that's a bad omega, but yes, 0.05 ohms. So that is number 5 as well for this one. Hopefully this video helped you out a little bit.